Hello, my dear students. Can you tell me, among these three test tubes, content of the which test tube contains chloride ion, which contains bromide ion, and which contains the iodide ion? So, let's see these things in this video. So, therefore, the topic of this video is confirmatory test for chloride, bromide, and iodide. In the dry test of the anions, we just guess the anion present. That means some rough idea of the anion. But through the confirmatory test only, we can confirm, 100% confirm which anion is present in the salt or this salt mixture. Now, the first question comes, when we should perform the confirmatory test for chloride, bromide and iodide. You know these three halides belongs to volatile acid group B, where in the dry test we use the concentrated sulfuric acid and water. So, after heating with concentrated sulfuric acid, if you get the evolution of pungent smelling gas that gives dense white fumes with a glass rod moistened with ammonium hydroxide solution, then it may be chloride. Like this dense white fumes with ammonia. Now, if you get the evolution of pungent smelling reddish brown gas and if you pass the gas in water, that color of the water will become yellow or brown, then it is your bromide. That is the difference with the nitrite. Okay. Now, if you get the evolution of violet vapor like this, then it may be iodide. So, what are the reactions involved in this dry test? Already I have discussed in my earlier video. Here the first test is that chloride ion, it's sulfuric acid. Here the strong acid releases weak acid, that is weak hydrochloric acid or hydrogen chloride vapor from the salt. And then this hydrogen chloride vapor with the ammonia vapor, with the ammonia, glass rod dipped in ammonia, then it forms this vapor of dense white fumes of ammonium chloride. Similar same thing happening here also with bromide, it forms the hydrogen bromide, same concept, release of weak acid by the strong acid. And then what happened? This hydrogen bromide is a reducing agent. So concentrated sulfuric acid is oxidizing. So this hydrogen bromide oxidized by concentrated sulfuric acid to reddish brown bromine vapors, and the sulfuric acid reduced to sulfurous acid, that means sulfur dioxide and water. Similar things happen with iodide. Here also after release of hydrogen iodide, what happened? It is oxidized by concentrated sulfuric acid to iodine vapor, and sulfuric acid reduced to sulfurous acid or sulfur dioxide and water. Now coming to the confirmatory test 1, which is silver nitrate test. Acidify few drops of sodium carbonate extract with dilute nitric acid. Boil the solution to expel carbon dioxide, and to this solution add few drops of silver nitrate solution. So let's see. So when you are adding this silver nitrate solution to your acidified sodium carbonate extract, and if you get this white precipitate, then it is the chloride. And moreover, that when you are adding this ammonia solution, this white precipitate is dissolved, then it indicates chloride. So white precipitate soluble in ammonia confirms chloride. Now, after adding silver nitrate solution, if you get pale yellow precipitate which is insoluble in dilute ammonia but soluble in concentrated ammonia, then it is bromide. And after adding silver nitrate solution, if you get the yellow precipitate insoluble in ammonia, then it confirms the iodide, presence of iodide. Now, what is happening here? This chloride with silver nitrate forming silver chloride precipitate plus sodium nitrate. It is double decomposition reaction, and in this reaction silver chloride precipitate is forming because it has low solubility product. Now this silver chloride with ammonia, it forms the silver amine complex which is soluble in water. So it is soluble. Okay. Now in case of bromide, here also the similar reaction, double decomposition, whereby silver bromide is formed, but this silver bromide, it gives that silver amine complex only with concentrated ammonia. Why? Because this silver bromide, it has the low solubility product. That means low solubility product means it will remain in the precipitate form or the solid form. So, in dilute ammonia, sufficient amount of ammonia ligand is not present so that it can push it towards this direction, that is formation of this silver amine complex. In concentrated ammonia, sufficient ammonia ligand is present, so it will push this towards this formation of this silver amine complex. Now coming to the iodide. So iodide also first reaction is same. It forms the silver iodide precipitate with silver nitrate solution. But this silver iodide is not at all soluble in ammonia. Why? Because this silver iodide, it has the very low solubility product. So it tries to remain in the solid state. That means in that solid state, it is tightly bound. Number one. And then number two, this silver amine complex, suppose if silver iodide reacts with ammonia, it forms a silver amine complex. This silver amine complex is not very much stable. That means its stability constant is low. When the stability constant is low, then the system will not have a tendency to move towards that direction. So as it has low stability constant, so this is low solubility product silver iodide cannot move towards this direction, that is forward direction, whereby the silver amine complex is formed. And the third reason is that iodide is very large anion and this highly polarizable. So the silver iodide, it has strong covalent character. Because of this covalent character, it is strong bond. So it is difficult to break and form this silver amine complex. That's why the silver iodide does not dissolve in this ammonia to form the silver amine complex. Now coming to the second confirmatory test, that is manganese dioxide test. Take small quantity of the salt or salt mixture in a test tube, add little amount of manganese dioxide and few drops of concentrated sulfuric acid and heat. So what you are getting, if you get greenish yellow gas and if you just hold this litmus paper, moist litmus paper, then blue litmus will become red. That indicates the presence of chloride. Right. Now, if you get this reddish brown vapor, means first of all you will get this reddish brown, then if you heat for a long time it will get a deep red vapor, and if this yellowish brown pungent smelling vapor, if it turns the moist starch paper yellow, then it may be bromide. Right. Now, if you get this violet vapor in this test and moreover this violet vapor turns the moist starch paper blue, then it is iodide, confirmed. Okay. Now what is the reaction involved here? See, chloride ion, manganese dioxide oxidizing agent, concentrated sulfuric acid also oxidizing agent. So here chloride is oxidized to chlorine and manganese, where it is in the +4 state, it is reduced to +2 state. And chlorine gas is evolved, which is greenish yellow gas. Right. Now this bromide, similar reaction, bromide is also oxidized by manganese dioxide and sulfuric acid to bromine, reddish brown bromine vapor, and manganese reduced to +2 state. Right. Same thing with the iodide. Here also iodide is oxidized to iodine by manganese dioxide and sulfuric acid. Okay. And here when you are holding this paper dipped in this starch solution, means moist paper dipped in starch solution, here it is becoming yellow color. That means this bromine, it is moist paper, no? So it is getting dissolved in that water and forming complex with the starch, which is yellow color. Similarly, iodine also with the moist paper, moist starch paper. It is forming the blue color complex with the starch. Now coming to the chromyl chloride test for chloride. Take small quantity of the salt or salt mixture, equal amount of solid potassium dichromate and few drops of concentrated sulfuric acid in a test tube. Heat and collect the evolved red vapor in another test tube. Add little amount of dilute sodium hydroxide solution to the test tube where the gas is collected. See what is happening. So you are heating this your salt plus potassium dichromate plus concentrated sulfuric acid. You will get this red vapor, and then you just take another test tube and just hold it at the mouth of this test tube in the inverted position to collect the gas. So you have collected the gas. Now here if you add this dilute sodium hydroxide solution, what is happening? Yellow colored solution is obtained. That indicates chloride. And again, to this yellow solution, if you add 2 drops of acetic acid and 2 drops of lead acetate solution, then what happened? You will get this yellow precipitate that indicates or that confirms this chloride. Right? Now, what is happening here? This is chromyl chloride test. Here, this sodium chloride and potassium dichromate. Sodium chloride means I have taken sodium chloride or chloride salt with potassium dichromate and concentrated sulfuric acid. It is forming the red vapor of chromyl chloride. Okay. Now, what is the mechanism? Why it is forming? Right. Here, in the first step, what happened? This chloride salt, sodium chloride, plus your concentrated sulfuric acid, the same thing, weak acid will be released, that is HCl plus sodium bisulfate, NaHSO4, right? Now what happened? This hydrogen chloride, it reacts with dichromate, K2Cr2O7 plus HCl. Then it forms the chromium trioxide plus here it will be KCl, potassium chloride, and plus water. Right? Now, this chromium trioxide combines with hydrogen chloride, that means CrO3 plus HCl. Then it gives you the chromyl chloride, red vapor of chromyl chloride, CrO2, Cl2 plus here it is water. So this is your red vapor, right? Now, if you balance this equation, then here it will be 2 HCl and 2 chromium trioxide and potassium also will be 2. And here it will be chromium, it is 2, that's all. Okay. So this is the mechanism of this chromyl chloride test, chromyl chloride formation. Now this chromyl chloride, when you are adding this sodium hydroxide solution, then this yellow colored solution, sodium chromate, is formed, right? And now this sodium chromate is in the solution. When you are adding lead acetate, then what is happening? This yellow color, yellow precipitate of lead chromate is formed, and this reaction confirms chloride. Okay. Now, there is some characteristics of this reaction. First one is, you look at here chromium remains in the +6 oxidation state throughout. Here also +6, here also +6, here also +6. And here sulfuric acid plays double role. First role, it is releasing the weak acid from the salt, and second role, it is dehydrating agent, so it is absorbing this water. So this equilibrium moves towards this formation of chromyl chloride vapor, red colored chromyl chloride vapor. Now the question comes, why this chromyl formation occurs only with the chloride, not with this bromide and iodide? Because in case of bromide, here hydrogen bromide will be formed. In case of iodide, hydrogen iodide will be formed. Both are reducing agent. So they will be oxidized by dichromate to corresponding bromine or iodine, right? And they'll reduce this dichromate to chromium plus 3. So this chromium trioxide will not be formed. So chromium trioxide, if it is not formed, then there is no question of the formation of chromide chloride. So this test is given by only chloride, or chromyl formation is given by only chloride. Now coming to the chlorine water test for bromide and iodine. This is also known as the layer test. Acidify few drops of sodium carbonate extract with dilute hydrochloric acid. Add 1 milliliter of carbon tetrachloride and few drops of chlorine water and shake. So here we have taken this sodium carbonate extract, which is already acidified. This is the aqueous solution, and here we have added carbon tetrachloride, that is organic solvent. So we can easily see that the two layers, one is aqueous layer, one is organic layer. Now what happens here? If this organic layer, by adding these things, doing this test, that means by adding the chlorine water, if these organic layers become yellow, then it is bromide. So yellow or orange color imparted to carbon tetrachloride layer shows bromide. On the other hand, when this organic layer becomes violet, that confirms iodide. And here this violet color disappears on adding excess of chlorine water. If you add excess chlorine water, then this violet color will go. Now what is happening here? You are adding the chlorine water, and that chlorine is oxidizing the bromide to bromine, and that bromine is getting dissolved in the organic layer. So in organic layer or carbon tetrachloride layer become yellow. Similar thing, the chlorine is oxidizing agent. It oxidizes iodide to iodine, which is violet color, and getting dissolved in the organic layer. So carbon tetrachloride layer becomes violet in color. Now here, that one thing I told you, that if you add excess of this chlorine water, then this violet color of the organic layer will disappear. Why? What happens here? In that case, this iodine, in presence of excess chlorine water, this iodine, here we are taking this excess chlorine, and then what happened? This iodine is oxidized to iodic acid, that is HiO3 plus here HCl, right? So iodine, chlorine oxidizes iodine to iodic acid, which is colorless and soluble in water. That's why that violet color of the organic layer disappears. So if you balance this equation, here it will be 5, then here it is 6, and here it will be 2, and here it will be 10. So that's why with excess of this chlorine water, that violet color of the organic layer disappears. So these are the confirmatory tests for chloride, bromide and iodide. Hope it is clear. Thank you.